Here we have a problem from the Furman WMT 2008 contest, and it asks us how many numbers between 1 and 8,000 are co-prime to 8,000, or in other words, don't share any factors with 8,000. So first what we want to do is split up 8,000 into its prime factorization. That's going to be 2 cubed, that gives us 8, times 1,000, which is 10 cubed, but 10 cubed can be split up into 2 cubed and 5 cubed. So that's our prime factorization for 8,000, which means that the list that we're going to have at the end is going to exclude all the numbers that have a factor of 2 or a factor of 5. So let's start writing down some examples of numbers that would be in our list. So 1 and 2 obviously wouldn't be co-prime to 8,000 because 1 is 1 and 2 is a factor, but 3 would be included. 4 wouldn't be included because it has 2 copies of 2. 5 wouldn't be included because it's a factor. 6 wouldn't be included because it has a factor of 2. But 7 would work. 8 is even, so it doesn't count. But 9 would work. 11 also works. 13 also works. 17 also works, and then we can continue on with this pattern. But now where are we going to end? We're going to finish up with the numbers 7,993, 7,997, 7,999, but there's no 8,001 because that's bigger than 8,000. So our set ends here. And now we need to count the number of times that we repeat this 4-digit sequence here. Basically, we're asking how many tens are in this number 8,000. Well, excluding this last bit that doesn't have a 1 digit, we know that 8,000 has 799, like I said, excluding these last 3 digits, times 4, because there are 4 numbers on our list for every 10 that we add. But then we have these last 3 numbers, so we're going to add 3, and this gives us 3199. So that is our first answer to this problem. On the next board, I'm going to give a different solution that provides a slightly different answer. And in the comments, I want you all to let me know which solution is correct and why. Or post in the comments maybe if you find my mistake in either of these solutions. All right, so let's go to that one. So first I want to start by thinking of our number 8,000. We know that 4,000 of the numbers between 1 and 8,000 are divisible by 2. But then we also know that 1,600 of these numbers are divisible by 5. And you might say, how do we know that? Well, 2 numbers for every 10 are going to be divisible by 5, those being the 5 and the 10. But now, similar to a problem that I did the other day, we want to remove all the things that we counted twice. And so the things that we counted twice are the ones divisible by 10, and there are 800 numbers between 1 and 8,000 that are divisible by 10. So to count the numbers being removed from our list, we have 8,000 minus 4,000 minus 16,000 plus 800, with this subtraction here being the numbers that we're removing from the list, and this plus 800 being the numbers that we're adding back because we counted them twice. And that gives us 3,200 numbers. So like I said, slightly different to our solution before. Let me know down in the comments why it's slightly different and which one is correct. And that's enough for now.